Alright, so we're back with another quick video. This time we're going to be talking about the addition rule for probabilities. So in the last video we talked about how to calculate the probability of A and B. In this video we're going to talk about how do we calculate the probability of A or B. So to calculate the probability of events A or B occurring, we first use the following formula, which is referred to as the addition rule. So the probability of A or B is you take the probability of A, add to it the probability of B, and then you subtract away the intersection. You subtract away the probability of A and B. And so why is that? Let me give you a quick little proof of this. So let's let this circle represent A, event A. Let's let this circle represent event B. Okay. So if we calculate the probability of A, that's the probability that anything in A occurs, right? And then the probability of B is the probability that anything in B occurs. Well, we have some overlap, right? We just counted something twice. What did we count twice? We counted this yellow area twice. So that's why we need to subtract away the probability of A and B, because it was counted twice. Okay, to an example. What is the probability of rolling an even number, what's the probability of rolling an even number or a 6 whenever we're rolling a single die? All right, so as we did in the previous video, I highly recommend write out what your events are. For this, I'm gonna let event A represent that we roll an even number. Event B is the event where we roll a 6. Okay. So we have been asked to calculate the probability of A or B. Or is our keyword there, okay? All right, and just to recap, it was the probability of A plus the probability of B, that's where it gets its name from, addition rule, minus the probability of A and B. All right, here we go. The probability of A. So whenever we're asked to calculate the probability of A, we have to think, okay, what's the probability we roll an even number when tossing a 6-sided die? Well, we know there's 6 possible outcomes we roll that die. That's our denominator. And how many even numbers do we have on that die? We have 2, 4, and 6. So we have 3 even numbers on a 6-sided die. So the probability that we roll an even number is 3 out of 6. Plus the probability of B. The probability we roll the number 6. Just the number 6, where there's only one 6 on a 6-sided die. So that's why we have 1/6 for that probability. All right, minus the probability of A and B. Probability of A and B. So that's the probability we roll on a single roll, an even number and a 6. Well, first of all, we got to ask ourselves, is this even possible? Okay, if you want to go back to a previous video where we talked about mutually exclusive events, we're rolling an even number and rolling a 6. Those are not mutually exclusive events. So it is possible for us to roll an even number of 6. In fact, a 6 is an even number. So the probability of A and B will be 1 out of 6. Because to roll an even number and a 6, that means we have to roll a 6. The probability of rolling a 6 is a 1/6. Okay. Just adding these together, well, the 1/6s, they cancel each other. So the final answer is just 3/6 or a half if you want to reduce that. Okay, that's the probability of A or B. Another example here. What is the probability of rolling an odd number or a 6? Okay, so here A represents odd number. And B, event B, represents we roll a 6. Okay, so the probability of A or B will be, one more time, probability of A plus probability of B minus the, what we call the intersection, A and B. Okay. All right, probability of A, rolling an odd number, it's going to be 3 out of 6 because there's 1, 3, 5. There's 3 odd numbers out of 6 total outcomes on a 6-sided die. plus the probability we roll a 6 is 1 out of 6, minus, well, A and B. This time, the events are mutually exclusive. Why is that? Because on a single roll, we cannot roll an odd number and a 6. So because they're mutually exclusive, the probability of A and B is nothing. It's 0, because it's impossible for that to happen. So in this case, the probability of rolling an odd number 6 will be 4/6, or 2/3 if you want to reduce. Okay. So those are just two quick examples to show you what happens when the events are not mutually exclusive versus when they are mutually exclusive. Okay, so here we go. Suppose the probability of A or B is 40%, 0.40. The probability of A is 0.25, and the probability of B is 0.35. The question is, what is the probability of A and B? So let's see here. We're going to begin things off with our formula. C plus the probability of B minus the probability of A and B. All right, so now we fill in the missing information, or excuse me, we fill in the information that we know. So A or B, we know that's 40%. That equals the probability of A, which we're told was 25%, plus 0.35, minus the unknown probability of A and B. That's what we're trying to solve for. Okay, so here we go. So 0.40 has to equal, well, we're going to take 0.25 plus 0.35. That's going to give us 0.60, I believe, minus the probability of A and B. All right. I'm going to subtract 0.60 from both sides. There's a couple different ways we can go about this, but I'll subtract the 0.60. And so we have a negative 0.20 is equal to a negative probability of A and B. And we know our last step is to divide through by -1. And our final answer is that, I'm going to flip it around here, the probability of A and B is equal to 20%. Remember, y'all, probabilities have to be between 0 and 1. You can't have a negative probability, and you can't have a probability that's greater than 1. All right, looks like that's it for this video here. I will catch you guys in the next video.